All right, folks, by popular request, I'm going to try and factor 9c. This is on page 129. Shouldn't be too bad. It is a pretty complicated question, but only using some of our very basic skills. We're going to start off and we'll try and factor everything that looks factorable, and that looks like a simple trinomial here, and here, and here, and here, and here. So we'll factor them all. We'll do the first step of factoring each of them just in one line. Move a little bit closer. Perfect. So my first fraction, that's p plus 1 divided by p plus 7, p minus 5. And plus this next fraction, again a simple trinomial, p plus 4, p minus 3, all divided by p minus 6, p plus 4, times p minus 6, p plus 2, divided by p minus 3, p plus 5. Perfect. Now from here, we can do one of two things. We could state our restrictions now, or we could write it in a bit. We could write the second portion of this in one fraction. So we'll try that first. So p plus 1 divided by p plus 7, p minus 5, and the second part in one fraction. So in my numerator, p plus 4, p minus 3, p minus 6, and p plus 2. In my denominator, p minus 6, p plus 4, p minus 3, p plus 5. So we have a few options here. One, we could find our lowest common denominator at this stage. If we do that, we need to do a little bit more work. It's a little bit bulkier. The other option would be to state our restrictions in an attempt to perform a cancellation before finding our lowest common denominator. So let's try that. We'll state our restrictions. In order to do that, we need to look at every single factor that's in a numerator at this stage. So restrictions, and I'm going to list them over on this side. Restrictions. My first factor I'm going to look at is p plus 7. I'm going to go left to right here. P plus 7 is not allowed to equal 0. Therefore, p cannot equal negative 7. So that's restriction number 1. Next is p minus 5. So p minus 5 not allowed to equal 0. So p cannot equal positive 5. There's my second restriction. P minus 6 is my next factor, is not allowed to equal 0. Therefore, p cannot equal positive 6. There's my third restriction. P plus 4, not allowed to equal 0. Therefore, p cannot equal negative 4. We're getting there. That's restriction number 4. And p minus 3, not allowed to equal 0. Therefore, p is not allowed to equal positive 3 here. Fifth restriction, and my final restriction here, p plus 5 as a factor is not allowed to equal 0. P plus 5 not allowed to equal 0. Therefore, p cannot equal negative 5. So there are my 6 restrictions. That makes sense. I have 6 unique factors in my denominators as we work through. Now that we've finished that, we can start to cancel out. So I see a p minus 6 happening in my numerator and denominator, and I see a p plus 4 as well. So I'm going to rewrite this line here, leaving me with, I'll leave the first fraction as is, p plus 7, p minus 5, and the second fraction now is reduced to p minus 3, p plus 2, divided by p, whoops, looks like I still have a p minus 3 term involved in my numerator and denominator, so I can cancel those out and erase this factor here. Good stuff. Luckily, I have performed all of my restrictions, so I don't need to worry there. And p plus 5. Perfect. Now, all of a sudden, it doesn't seem so intimidating. At this point, I can find my lowest common denominator. That's going to be a combination of all the factors that are involved in my denominator. So my LCD equals p plus 7, p minus 5, p plus 5. Nice and easy. If that's the case, I'm going to implement this lowest common denominator, meaning I need to multiply my first fraction, and sorry, I'm kind of squeezing it in on the wrong side of the equal sign here. I need to multiply my the numerator and denominator of my first fraction by p plus 5. And the second fraction, I need to multiply by p plus 7 and p minus 5 in my denominator and numerator, p plus 7, p minus 5. There we go. Now remember, the order doesn't matter as I'm implementing those in my numerators and denominators. And let's move forward. So now I can write this all as one fraction, right? So I have p plus 1, p plus 5 plus p minus 5, p plus 2, p plus 7 in my numerator, all divided by my lowest common denominator, and that's p plus 5, p plus 7, p minus 5. So it still is a pretty complicated sum of fractions that we're dealing with here, but at least it's not so bad as it would have been if we didn't strategically perform our cancellations in the second line that we wrote. Now we can start distributing. So the first FOIL brings us to p squared plus 6p plus 5. And then what I'm going to do, I'm going to first perform my expansion on the first two pairs of brackets, and then I'll expand the p plus 7 after. So that leaves us with p squared minus, p squared minus 3p minus 10 times p plus 7. Now when I'm expanding this p plus 7, I need to multiply the first p times every term and then the 7 by every term, right? So we'll do that on my next line after I put my denominator down. So that's p plus 5, p plus 7, p minus 5. Perfect. We're still going here. Leave the first part the same, p squared plus 6p plus 5 plus, and all of a sudden here I have a p cubed term, minus 3p squared minus 10p plus 7p squared minus 21p minus 70. Perfect. There we go. Is it long? Yes. Is it really confusing? Not really. We're just following through with all of our strategies. It's just a little bit clunky. P plus 7, p minus 5. And so my numerator, we'll kind of put them in order. I know there's a p cubed term, p cubed, and then again, I'm collecting my like terms. So I have p squared minus 3p squared plus 7p squared, so that's plus 5p squared. And then I have plus 7, I have 6p minus 10p minus 21p, so that's negative 25p. And then let's see here, my final term is a negative 65p, all divided by p plus 5, p plus 7, p minus 5. And at this stage, we do need to try and factor the numerator. We don't have a lot of strategies in terms of factoring a 4-term expression that has a cube term involved. Our number one strategy, the only strategy that we have covered that could be able to handle something like this would be our grouping. Looking at this right away, I'm not sure if I see any kind of grouping that can work here. Let's just try and work it out. Oh, sorry, that's a wrong term. There should be no p on the final 65 term here. We'll try grouping the front two and the second two. I'm actually, just because this is kind of an aside, as we're trying to factor our numerator, let's try it in red here. So p cubed plus 5p squared, we'll put those in brackets, plus negative 25p minus 65. Perfect. So my common factor out of the first two would be p squared, leaving me with p plus 5. And the second pair, let's see here, I can take out 5. I'll take out negative 5. So negative 5 as a factor. 5p minus 13. So that doesn't help me. I really don't see anything in particular that we can use right here, folks. So I think we will we'll call it there. We'll say that's unfactorable. We can double check. We could try a few other grouping patterns, but I really don't think it'll work here.